All right, in 7.1, we're looking at some of the basic exponent rules. So probably on the up and up with if I'm multiplying, then I add my exponents. If I'm dividing, I subtract. Another one, anything to the 0th power is going to give you 1, and what negative exponents do. So let's run through those 4 main properties real quick. If I have a to the m times a to the n, then since I'm multiplying here and the base is the same, then the rule tells me that I keep my base and add my exponents. So let's say I had a 2 to the 5th power times 2 to the 7th power. I have the same base, I'm multiplying, so I'll keep my base and add my exponents. So 5 plus 7 gives me 12. So this is the sum product property. And then we have, if we're dividing, so let's say I have a to the power of m divided by a to the power of n. Then again, notice that I have the same base, and the property tells me if the base is the same and I'm dividing, then for my exponents, I take the top exponent and subtract the bottom. So the order there does matter, the top minus the bottom. Now this can give way to if m is less than n and I subtract them, then I am going to end up with a negative number. So let's look at that real quick. Let's say that I have x squared over x to the 5th power. I see that I have the same base. The operation is division, so that tells me I need to subtract the top exponent minus the bottom exponent, keeping the same base. So I get x to the power of 2 minus 5, which is negative 3. Now you're going to see in Hawks, all the problems when you're simplifying these exponential expressions will ask you to write it without negative exponents. You know about things that are grammatically correct. We have things that are also mathematically correct. One of the things that is not mathematically correct is to leave an expression with a negative exponent. So there is a property that allows us to deal with that. When I have a negative exponent, one way to think of it is by taking the reciprocal. So if I have a to the power of negative m, negative whatever, then that's the same thing as 1 over a to the power of m. So in this way of thinking, the negative kind of indicates that it's in the wrong spot in the fraction, right? Technically this is over 1 right here. A to the negative m, it's in the numerator. The negative fraction essentially tells me this should be in the denominator, so just swapping the position of it. I hope the glare is not too bad on that. So a to the, I can block it. A to the negative m over 1 is equal to 1 over a to the m. So back to this previous example, x to the negative 3, rewritten with just positive exponents, would be 1 over x to the 3rd power, right? It's just switching positions inside the fraction. All right, so the last property of the exponent rules, or the last rule in the exponent rules, is what to do when I'm raised to the power of 0. So that property tells us that if I have anything, it could be anything, raised to the power of 0, then this is automatically 1. So it doesn't matter what a is, if it's raised to the 0th power, then I end up with 1. Right. So we want to be able to use these properties to simplify exponential expressions. And our end goal with these is to be able to solve exponential equations, which we'll see in 7.1. So let's do a practice problem. So let's say that we have x to the 4th, y squared, z to the 3rd, all over x squared, y to the 5th, z, x to the 7th. So I have this exponential expression, and I want to use all the properties that we just talked about to simplify this. So a simplified exponential expression will have 2 things. It will have one of each base. So you see here I have bases of x, bases of y, and bases of z. When it's fully simplified, I will have 1x, 1y, and 1z. So we need to use our properties to be able to combine all the x's, all the y's, all the z's The second thing is that all of our exponents will be positive. So those are the two main things we're looking for in simplifying. Combining all of the same bases and eliminating any negative exponents. So I'm going to start by combining all of my same bases. So in the numerator, I have x to the fourth times y squared times z cubed. These are all being multiplied together, but all the bases are different, so I can't combine any of those. In the denominator, I have x, y, z, x. All of these are being multiplied together, and here we see we have common bases. So the property of multiplication for our exponent rules is going to come into play. I have x squared times x to the seventh, which I can combine by adding the exponents together. So I would have the numerator stays the same, x to the fourth, y squared, z cubed, over, combining my x's, I have x to the ninth, y to the fifth, and z. So I've combined, the top now is essentially in simplest form, and so is the denominator, so I can work top to bottom now. I still do have a common base here, so I have x to the fourth over x to the ninth. That operation is division, and we know the property tells us that we can then subtract the top exponent from the bottom exponent. So 4 minus 9 gives me negative 5. So I have x to the negative fifth. Same thing with the y's. So y squared divided by y to the fifth. The property again tells me I can subtract top minus bottom. So 2 minus 5 gives me negative 3. So y to the negative 3. And then likewise with the z's. Notice the z in the denominator doesn't have an exponent, so it's an understood 1. All the different bases will have an exponent, so if there isn't one, then it's an understood 1. So z cubed over z to the first power. Again, this is division. The property tells me that I can subtract the exponents, top minus bottom. So 3 minus 1 gives me 2, so I end up with z squared. All right, so the first requirement for a simplified exponential expression has now been satisfied. I have 1x, 1y, and 1z. The last thing to take care of is the negative exponent. So I have x to the negative 5, y to the negative 3. These aren't technically mathematically correct. So I want to use the property that we have for the negative exponent to rewrite this with only positive exponents. You can think of this as over 1, so now it has that fraction feel. Remember, the negative exponent essentially tells me it's in the wrong spot. So since x to the negative 5 is in the numerator, I can take its little negative and move it to the denominator, right? So likewise with y to the negative 3, that negative exponent indicates it's in the wrong part of the fraction. It's in the numerator, so I'll move it to the denominator. Z has a positive exponent, so that indicates that it's in the right spot. So rewriting this with all positive exponents, draw a little arrow. X to the negative 5, it's going to move to the bottom, and once I move it, I'll take its negative to indicate now it's in the right spot. So the only thing that's going to stay will be z squared. X and y will be moved to the denominator. So I'll have x to the fifth and y cubed. And now again, I have all single bases, all positive exponents, so I have simplified the exponential expression.